Hello. Adjusting. Okay, thanks. Okay. I was looking, and this is one of the nicest screen that I've gave presentation on. It really looks amazing. Not like a regular conference room. Really nice. And it's not a movie today, but we still have 3 main characters: Memcache, Redis, and Aerospike. And I'm going to say a few words about each of them, how you can add them to your stack. So, are you using some sort of in-memory NoSQL? Great. Thank you. Let's see if it works. Okay. So just a few words about myself. Technical guy. It's nicer to say than saying that I'm a geek. And my Stack Overflow user. Now I don't expect you to remember it, but it has some meaning in all this presentation context because it's actually a Redis handle. Stack Overflow is a big user of Redis. There are lots of things saved in a Redis database. And I'm working in the travel industry. We're doing software for B2B travel agencies, so we're not so well known in the B2C space. But if you, I don't know, if you have some friends that do own like a travel agencies, or if you want to open one, we have the software for you. We have clients like from Central America to southeast of Asia, or all over the world, and a lot in Europe. So this is what we are doing, and this is what we are building at PlugAndTravel. Okay. So the first thing that comes to mind when talking about in-memory NoSQL, it's the performance. I mean, it's clear that accessing data from RAM is much faster than accessing it from the disk. And it's much smaller latency. You get it much faster, not to mention if everything goes through a network. But there is another big advantage in using in-memory NoSQL, and that is scalability. Maybe you don't see it, but all the big applications on the market today are using some form of in-memory solution. Facebook, for example, is using Memcached a lot. Like probably all the things are stored in some Memcache server. For sure, more Memcache server, not just in one. And Twitter, for example, stores all the timeline in Redis. They have their own Redis fork from some point, but hopefully they will merge it into the main one. Stack Overflow, also a big user of Redis. So just think that if they would stop these in-memory solutions, for sure their applications will not be that scalable. So they will not answer our request that fast, if they will answer. So this is how we started at PlugAndTravel, thinking about some in-memory solution. You first build like a small application, put it like on a server. You don't care about things like performance, scalability, it works. But then if the business is doing great, which of course is a good thing, now you need to scale your application. So you need to move from one machine to more. And you're doing this by adding a load balancer. Now, when you put at least two machines under a load balancer, you start having some problems that you need to figure out how to solve them. You need to think about where is now the best place for your session. Because if the session is again in the in-memory, in the application memory, it will not work because it's either on one server or on the other. It cannot go to any of them. Then you might have something like search results, like taken from the database or maybe from an external endpoint, stuff like this. So those might not go into session, but you still need to save them in the application memory. And the static items, I'm referring like things like you are loading when your application starts. So you probably have some static things that you want to load and not to ask them every time from your application, so it will go faster. Now, when you have only one server and it's loading it from the database, it seems like a good solution, a good idea. But when you have like 4 servers and they're always loading it from the database, things might not look so nice. Now, if you were like maybe 10 years ago, you'd solve all this by using sticky sessions. So you put like the cookie on the load balancer, and this way the load balancer knows that you ended up on server number 1, and it will keep redirecting you to server number 1. So problem solved. But being 2017, you want your request, the client request, to be able to go to any of the machines under the load balancer, to be able to scale, because the load balancer can find out how much load is on any of these machines. Usually they know how many connections they have to any of the machine under the load balancer, so it can really balance the load. So sticky session is working, but probably it's not the best solution. And it also, if you're using sticky session, you'll not be able to auto-scale. And if you're using some kind of cloud platform, I think your destination should be autoscale. I believe your destination should be autoscaling. In our case, for example, because we're working with B2B travel agencies, they usually are closed during the weekend, so we get many less searches. We don't get so many requests, while during the weekdays, when they're working and they have clients doing reservation, we get many more requests. So there is an advantage on autoscaling, which can be really explained to the managers by there will be a cut of costs if you don't need the same number of machines running every time. Sorry. Now, probably the majority of us are doing some kind of web application, some kind of MVC application, like you show data from the database, you display it to the user, edit something, save it back. And this kind of developing these kind of things, also in our case, might make you consider the database as a solution for everything. You think the database, like, okay, the best place to store your session and your search results or stuff like this, but they were not really meant. They were not created to solve such a problem, because you don't need on the session. You don't need the disk persistence. You don't need all the ACID stuff. You don't need to be like all the things atomic, and because it's a little too much. You need your session to be fast. You need to load it because it's loaded on every request. You need it to be fast. You need it to be responsive. While the database is more, they are more created with like AC transactions in mind and stuff like this. So the database is a solution, and there are many session providers which are working with, I don't know, SQL Server, Oracle, MySQL, and stuff like this. But it's not for sure it's not the best solution. And then you find out about some in-memory key value stores and stuff like you read about Memcache, which is like probably the first one. Then you find out that there are more of them, and I think that this could be a good solution for your scaling problem. And now you're going to talk to your, I don't know, team leader, architects, senior management, and trying to convince them that you should adopt such a solution. You should go for some in-memory NoSQL. And if you are going to do that, you need to have some things in mind. You need to consider some of the things. So if you're going to talk to the management, they're going to ask you how much it will cost. How many machines do we need? and you need to be able to do your calculations. So I just brought some numbers from AWS and Azure, and you can see how much, or what is the cost per, an average cost per gigabyte RAM per hour. So it's easy to calculate how many gigabytes you need, and then you can see exactly what kind of machine, and then you can make the calculations, and you can come up with some really hard numbers to your management, which can approve it or not. Okay. Now, talking to your fellow developers, the first thing which it will come to their mind is that if you stop that machine where, I don't know, Redis is installed or Memcache, all the data will be lost. So because it's volatile, it's not saved on the disk, being in memory, everything, you'll lose everything. So you're probably going to be scared of this situation when everything can disappear. And in the case of, for example, in case of Redis, you can do backup, the same with Aerospike. And backup, even if all these like new solutions have things like replica sets, like replication factor in the cluster, backups are really essential because it will save you when something goes, when some developer does something really, really stupid or some mistake and deletes all the data in staging or even production. So even if you have like disk persistence, so like everything which goes to memory, it's also saved on the disk. It's still good to do backups from time to time. So besides Memcache, which is a little bit different, Redis and Aerospike do support it. So you can think of the next step, which is now if your business will keep growing, you'll need to be able to scale also such a solution, also your Memcache, your Redis. And they do support server-side cluster, both Redis and Aerospike, which means that you can add machines on the fly and all the cluster will rebalance itself. So it will do all the migrations automatically behind, and you will not have to take care of anything. Besides Memcache, which has like more like a client-side cluster, and that will mean some data loss. But it can still scale with some data loss. Now, if you start reading about these products, you see that they're not the same. They were not created like to solve the same only one problem in mind. So now we're going to see about some details of each one of them, and we're going to see how they were created, what they are trying to solve, and this way you can see which one fits best to your own stack. Yeah, Memcached is the veteran here. It's probably the most used one. If Facebook is still using it and is doing a great job, then I think it's a good solution for each of us. And it's a very simple. It has a very simple API which allows you only to work with key and the value. The value is just a simple value. You don't have like something like a list or a hash there. You only have like the immutable API. You can like delete key, update key, expire key, and stuff like this. It's got some limitations which can be a little annoying for 2017, especially that the value cannot be more than 1 megabyte, and you'll probably end up with key underscore 1, key underscore 2, so you'll separate a big key into many smaller keys and keep track of their number and stuff like this. So okay, you can go over that issue. This is created like to be a simple out of process caching solution. So it doesn't have any of the scaling features on server side. It's just a simple cache. So you need always to take in consideration that your data might not be there in your Memcache. So you need to be prepared to fetch it, like I don't know, from an external endpoint, to fetch it from your database again, because it might not be in there. And if you think of that in mind, You don't have a problem that it doesn't have server-side cluster. It's okay to have only client-side because you can still add and remove machines from your cluster. Okay. Moving on with Redis. It's a very popular tool. It's you can have it on both AWS and Azure as a platform, so you don't need to start any infrastructure, any VM, and install it. You just click some buttons or some API calls, and you have a cluster of Redis. I think on AWS it really supports clusters right now. So you're ready to start in just a few seconds, probably. There are big companies using it. There's a very big community behind it, and it's really open source. It doesn't have the community and enterprise edition, like you'll have to pay for some extra features or stuff like this. Everything is available to you. That's why it's a really popular tool. Now moving along, and if you start reading more about it, you find out that it has only one thread to serve all the client's requests. So all the requests that goes to it are served by this thread that you need to pay attention. If you have a long-running process, if one of the clients will ask for some big data or some kind of big processing, it will affect all the other ones. So all the other requests will be queued. So you need to pay attention to this. Redis was created more with solving some live data analytics in mind. So this guy that created it wanted to solve some wanted to do some small updates to the database, but really fast. So it was a really fast update sending. So it's not sending like a lot of data, but just small increments, and he wanted like very fast performance. So it ended up creating a lot of data structures on the server side. And once you understand these data structures and you use them correctly, you're going to benefit of all the Redis power. You're going to use it at probably its maximum. It has some server-side procedures, so you can write some nice code in Lua and put it on the server side, and you can execute it there. Like, you don't need to get on the client, all kinds of keys. You can make some calculations there, but again, you need to be aware of the long-running processes that will affect the other clients. Initially, it was created with just a replica set, so like a classic master-slave replication. Now it also supports cluster, so you can have a partition of data sent to different replica sets in your stack, in your solution. Does support persistence, so all the data all the writes that will go to RAM will also be saved on disk on some append-only file. You can read it very easily. It's very clear, and you can take backups from time to time of your data. Now we're going to see about these data structures, and I do have like a small demo about it. I have an application that it's a small application that uses the Redis as the only database behind. So I'm trying to see how we can do things that you do in a web application, and you don't need some like a MySQL or some other database behind it. And I will put here, we'll see exactly what the application will be sending to Redis. So I have like a users page, and we can see here we have a last registered users section, and normally for such a thing you'd use like a list, right, to save your users. So we're going to see exactly what was sent behind, and you can see here, hope it's clear. So you have a, I'll try to translate it, you have a left range, so on the list called last registered users, starting from index 0 until the end. -1 will mean the end. So you're asking, give me the list starting from left, index 0 until the end. And this is the key of the list. So in this case, the value is a list. So you have a key which the value is a list, and you can add to the to this list. You can ask to make a recursion on it from the left or from the right, depending on what you are trying to solve. So I'm going to create a new user. And we can see what happened behind. I think this one. Okay. So we have the after left range we have a set on a hash. So one another type in Redis we have a hash set. So which has like you can think of it like an object, like a dictionary. It only has like one level, so you don't have nested levels inside. And you can see first is the key of the hash. It's users and my email, and then we have the, like, you can think like the fields, the name of the field and the value and so on. So this is exactly what gets sent to Redis. Then I'm saving something in the list that we've seen at the beginning, last registered users. I'm putting there my email, which will act like key to this hash set, and then I'm asking again, give me this list from the left, from 0 to -1, and here is the last registered users. And now I'm going to the user details, and I'm seeing. Now one of the questions that I held like a Redis workshop in some database group, and the main question is, how do you do select? Everybody was trying to skip to, I don't care, left range, or how do you do the select? And the question is, with Redis, it's always on every question is, the answer with Redis on every question is, you build another structure. It's geek jokes. So you need to understand the structures behind it, and once you understand them, you can also do select, which is not easy. You need to create like a lot of structures. But it has, additional to what I showed, it has some sets. And on the sets, you can do mathematical operations like union, intersection, difference. So these things you can do to do the select and the predicates on the where. Okay. Now back to where we left with Redis. Well, once we went live with this, we found out that we started having timeouts at some point, and it's not necessarily because of Redis. I mean, usually when you add Redis to your stack, like to save your session or stuff like cached results or some other things that you want to put like in a in-memory solution, you make calculation of how much RAM do you need. You are doubling it just to be on the safe side. And then if you're on AWS, or if you're on Azure or some other cloud where you're putting like some VM with Redis, it's not necessarily, you look for quite cheap machine. And for example, on AWS, there are the T2 machines, the burstable ones, if you know, which can give you a lot of RAM. Doesn't give you a consistent CPU, but you actually don't need it so much in case of Redis. But it also gives you a very poor networking. So those timeouts might not be because of Redis, but because you're asking a lot of data from that Redis instance, and the network can't even handle all that traffic. So you need to pay attention to also, when you make the calculation, pay attention also to the network, how much data you can transfer. And which is not really simple to find out when you are on AWS, because they don't give you any hard numbers. They just tell you that network is low or network is moderate. They just give some attributes. You need to pay attention to these long-running processes, because being a single-threaded, it can only serve on one request at a time. So just a simple command like keys, which returns all the keys on the server, or flush, which goes and deletes all the keys, can bring your replica, your master from the replica set down. Inside the replica set, there is a Redis Sentinel that you need to set up, which will queries from time to time. I mean, default is like every 30 seconds, queries the master. And that query also needs to get answered from the single thread. So if the thread is busy doing something else, it will not answer to the Sentinel, which will promote some other slave. A slave will be promoted as a master. So it can, and this can happen quite frequently during the day. So it's really not something that you would want. Moving along to Aerospike. Aerospike was created to solve the, let's say, our today's problems, scalability and performance. If you want a tool that doesn't have so many things on the server side, so many data structures, but you want it to be fast and you want it to be able to scale, like to have like a cluster which you can really easily add machine and remove them, Aerospike is a good choice. It has here we can find the Enterprise Edition, which has some extra features that you will need to pay for. And it's gaining a lot of popularity. Kayak, I don't know if you're aware, but it's a big brand in the travel industry. It's also used in the advertising industry, like if you need to serve fast ads to your customers, it would be a great choice. And it's easy to start. You can find it configured and available like a Vagrant box if you want to start developing and playing with it. And on AWS and Azure in the market, you can find VMs already set up with Aerospike. So bringing one up, nicely configured, so bringing one up, it's just a matter of minutes. And you can start playing with it and do tests and everything that you need. So once you go with Aerospike and you start finding more things about it, you see some similarities with Redis. It does have some data structures, but not that many as Redis. Again, you find some support for Lua, a nice C-like language. You can do some store procedures. But probably its main power stays in the storage models. So you can configure like one cluster to have different storage models inside. And we're going to see exactly which one will fit your description better. Inside the cluster, the replication is synchronously, which can be a little problematic. For example, on Redis, the replication is synchronously, which has, of course, some other problems like consistency of data. You can find out then it has something like namespaces, and initially you read that they are similar to databases in a classic SQL solution. But if you go deeper, you'll find that they're totally different, because once you configure the namespaces on a cluster, you need to restart the whole cluster, for example, for adding more. And the namespaces are just like a container to put the storage model. So one namespace, one storage model. So for example, on a cluster, you should have like maximum 3 namespaces, because that's how many storage models it has. So you don't need to add like one namespace per client. If you're having multiple clients, you'll not be able to separate the data based on namespaces. Then it has something like sets, which are very similar to databases. And the bins are the columns inside the databases. And you have the primary key, and on the bins, on the columns of your set, you can have secondary indexes. And you cannot make queries on these bins unless you create a secondary index on it. And just a few words about the storage models, because I think this is its main power. You can have everything only in RAM with no persistence on disk, and this will be the fastest solution. If you want some persistence, you can on every write operation, data will also be saved on the disk. And the most interesting one, it has a special storage model for SSDs. I'm saying it's special because it uses something like which is really trendy today, like the append-only database. So every write that goes to the database, it doesn't overwrite an existing value. It's always put on an empty space, because that's what makes the SSD faster. Overwriting some existing data, it's much slower on an SSD than writing on a space that is zeroed out from the beginning. And it takes advantage of this feature of the SSD. But because of this, when you're putting a disk, when you're attaching the disk to your VM, you need to be careful not to mount it. So it must not have a file system on it, because the file system will act on its own and will overwrite some data that Aerospike will write, and you'll have conflicts on restart and it will stop working. So don't put a file system on it, because Aerospike handles its own system inside there. And also, if you're attaching the SSD to your Azure instance, to your AWS instance, it needs to be completely zeroed out before you start working with the disk, in order to get the best performance. And now I have a small demo about Aerospike. We'll add some data to it, and we'll just make a simple query, which initially will fail because there's no index. And after that, it will work, because we will create the index and we'll see the nice interface to create the index. So I think the code can be seen here. So I have 3 users, which I'm saving. And then I'm trying to do a query on the city. This one, I have 2 users on Yash and 1 on a different city. So I'm trying to get the users which are from Yash. And initially it will fail just because I don't have any index. So here I have a VM started with Vagrant, where Aerospike is running. And then let's see which one. Wow, crash. And if you see here, it tells me index not found. So it did save the data, but the index is not there, so it cannot do any select. And there we can go here. This is the console of Aerospike. And we see that we don't have any index. And I'm going to add one. And the bin is called city. You can pick up if it's a numerical string, even for example in my case that I have string values, if I will put numeric, it will not take into consideration the string ones. So it will not index the string ones, it will just try to find if I have like numeric values inside the bin. And the same with string. If I take and do a string index, it will not, if I have that bin using also some numeric values, it will not take them into consideration. Okay, so I did create them. I create the index. You can see it here, it appeared, all the details. And then running again the query, it will give me the 2 emails that were from the city that I queried. And we can look at the... So this is how I'm saving stuff, and this is how I'm querying stuff. So you can see here a query. I'm setting the namespace, the set name, which is the table, like the column that I want to retrieve, and the filter, which is on the city column. It's pretty easy to start with, and it's actually interesting to do something like this. Sure. I think you can also add an index on. To be honest, I didn't try this. In our use case, we only have the index only one column, but I think you need to add more indexes. I mean, like an index for every column. That's what I think. Yes. I wasn't prepared for the live demo. Yeah. I can find out and I will tell you after. Okay. So once you go live with Aerospike, in our case there were some things that we found out on the hard way. I was mentioning that replication inside the cluster in Aerospike is synchronously, which means it wants to have a really good and reliable network, because otherwise you will have like partitions, brain splits, stuff like this will happen. One node will not see the other ones. And they don't recommend putting different nodes on like different availability zones on AWS, which is against AWS recommendations, which said that if you want to have the high availability, put different nodes in different availability zones, because there are different physical locations separated tens of kilometers apart. So if the hurricane hits one, it's very unlikely to hit another one. So they don't recommend this, but I have like a belief that a lot of people that are on AWS using Aerospike are using it like this. So different nodes on different availability zones. You can play with the settings and put like a bigger timeout on the cluster. So you'll not have you'll not have all the brain splits. For example, one of the problems when putting data on SSD is that all the secondary indexes, all the indexes that are created, are kept in memory. So they're not kept on the disk at all, only in memory. This makes it fast, but on a restart, if you have a lot of data and many indexes, it needs to recreate them in memory, which can take a lot of time. And in our case, the cluster that we're using right now, it takes between 6 and 7 hours. So if we have like a brain split and we're going to need a restart on the node to rejoin the cluster, we know that it takes 6-7 hours. Now, usually when you deploy such a cluster, you do take in consideration that you might be able to run with -1 nodes. So, but I'm not sure that you'll take in consideration that you might need to run with -2 nodes, because you have a period of 6 hours when you're exposed. If something bad happens, it's nobody will like it. There is the option of fast restart, unfortunately only available in the Enterprise edition, so you need to pay for the license. What it does, it saves a copy of the indexes in the memory of the operating system. So it has a copy in RAM of all the indexes. And this allows you to restart in a couple of seconds. Now, I'm just guessing, if they would have this feature from the Enterprise available in the community, for sure it will have much more popularity, and probably it will be interested to many more developers out there to start using it. Like, just a message for them. There is a limit also here. The row size cannot be, so the sum of all the bins cannot be more than 1 megabyte, but this is mainly only when you're using SSD, but this is mainly because how they are querying the data to make it faster. So, and because they're using their own system on the disk. So you need to pay attention. You need to pay attention even if you're running on SSD, and you can easily put like a couple of disks of 500 gigabytes in AWS and Azure. You still are bounded by the amount of RAM you put on the machine, because if you put a lot of indexes and they get filled, it will simply, that node which got filled, it will simply stop. So if you need to restart it, you need to add one more node to migrate the data and to make room for such some space in the RAM. Okay. I made a separate slide for this because I find it really important. What we found out is network is really important. After running for Aerospike, we have it for around 1 year, and Redis for maybe 3 years. Not sure exactly. We found out that at the beginning we didn't take it into consideration. And for example, we tried running clusters, like I said, with the burstable machines on AWS, the T machines, which do provide the RAM you need, and it has good CPU, but they are really bad on the network. And every time that we try to have a cluster on the T machines, every time we got a partition, a brain split. One of the nodes separated from each other. So you need to probably need to run at least with some M4 machine if you are familiar. So look for the network transfer, make some calculation, maybe put some alert. You'll have to make your own test, because like I said, the AWS, for example, doesn't give you some hard numbers on the transfer. But with careful monitoring and some alerting, you might take advantage of even smaller machines. Okay. Now, a small review of what we covered. The in-memory solution, besides performance, will give you scalability, which probably at some point, if your business goes well, you're going to need it. And if you are also using some cloud environment, some cloud solution, it's also the path to auto-scaling. And probably this should be your destination. Memcached is a simple machine which allows you to put data, like to use like a secondary cache, and from time to time you need to take in consideration that the data might not be there, so you need to reload it from the disk, from the SQL or from the external endpoint, wherever you have it. Now Redis, it's more advanced. It stands for, this is an acronym, Redis, for Remote Dictionary Server. So again, think about the data structures that it has on the server side, and once you understand them, you will have it at its biggest power. Moving on to Aerospike, it was created with cluster from day one, using stuff like replication factor, similar to Cassandra, for example. And it's nice that you have these hybrid approaches, and inside the cluster you can have a namespace which is RAM only. You can then have a namespace which is RAM plus persistence, and then you can also have one which saves data on the disk. So then you have the option from your application to save data wherever you think it's necessary, and even moving it. And most important, do make the calculation also for the network. That's it. So if there are other questions, if not.